In our last video, we talked about variance, standard deviation, and mean absolute deviation. So today we're going to actually talk about z-score, which is related. It has to do with the standard deviation. You actually use it, but what it does is tells you how far a specific number is from the mean. So before I show you a picture of what exactly that looks like, we'll go ahead and go through our formula. So it's x minus mu divided by sigma. So again, this right here is mu, it's a Greek letter, and this is sigma. So when you hear those, that's what those words mean. So what this whole formula, what each of these stand for, let me go ahead and skip that. Z is of course the z-score. That's pretty obvious, I think. Then we have x, that's our number from the data set. So what number are we looking at? So number from the data set. Then we have mu. Mu is our mean. And then we have sigma, which is our standard deviation. Okay, so looking back at our formula, we take our value, subtract our mean, and then divide by our standard deviation, and that will give us the z-score for a specific data value. So this right here is what's called a bell curve. And what's important about the bell curve is to know that most of your information, anytime you're doing something with stats, will fall in this area right here between one standard deviation below and one standard deviation above our mean. So this out here is more than one standard deviation, and this is less than one standard deviation, or I'm sorry, one standard deviation away, negative, so it's smaller. So when we're looking at this value, or this information, we find our mean, we find our standard deviation, and we add that to the mean, and then we subtract it from the mean. And they actually did it twice in this picture, so let's go ahead and do that with some information. So here we have an observation of 14.75, and really what that represents, the 14.75, means that our x is our 14.75. So that's the value that we're looking at. Then we have our population mean, and of course you already know that population mean, or mean, is just average. Population means from our information that we're using. So that is our sigma, our mu, which is 12.2. Then our last bit of information would be our standard deviation. This one is the sigma. So sigma, and that is 1.75. So referring back to that formula we use, it is z equals x minus mu divided by sigma. So we plug in our information now. X is our 14.75. Mu is our 12.2, so we subtract 12.2, and then we divide by our standard deviation, which is 1.75. This gives us approximately 1.46. Remember, this symbol here is approximately. So this 1.46 means that this number, 14.75, is about, we'll say, about 1.5 standard deviations away from our average, which is 12.2. So if we wanted to make a bell curve that would look something like this, we can go ahead and come right back here. This score right here, our mean, we were given that as 12.2. Now we were also given that the standard deviation was 1.75, so we add 1.75, and we also subtract 1.75. That will give us these values right here. So when we add the 1.75, we end up with a total of 13 0.95. When we subtract our 1.75, we get 10.45. And then if we add it again to the 13.95, we add 1.75, we get 15.7. And then over here, 10.45, and we subtract our standard deviation. Over here, this number would be 8.7. All right, so here is what our values for our bell curve would look like. So what I was saying earlier is that most of our data is going to fall in this portion of our bell curve. So most of our information will fall in there. And if you remember the dog example from the last video, remember how there were 5 dogs, 3 of them fell between, there were 2 lines going horizontally like this, 3 of them fell in here, 1 was above and 1 was below. So when we had the 3 in here, that corresponds to this information here. When we had 1 above, this would be above, our positive direction, and then 1 below would be down here. So if we're looking at this and we know that our z-score that we calculated using this information, our z-score was a positive 1.46 about. So what this means is positive means it's above where most information falls, so it's up here, and it's close to, let's say, 1.5 standard deviations away. So it's going to fall somewhere out here. This is where it would fall. That would be our z-score. Now let's say we got a negative number, negative 1.46. If this happened, that would mean instead of it being above in the positive direction, we'd be below in the negative direction. So it would fall somewhere down here. So this number represents 1.46 standard deviations away from our mean, or in the opposite direction if it's negative.